right, this is coordinate grids, triangle B for November number corner, which is actually days 6 through 10. Get out your worksheet. We are on the part that says triangle B, which should look like this part of the worksheet. Now I have put what the triangles look like for days 6, 7, 8, 9, and 10. Let's focus on day 6. So let's sketch this triangle right here on day 6. So when you're drawing your triangle, please remember that here we can see this is exactly a right angle because it lines up with the lines on the coordinate grid. All right, here I have put an excerpt from our page that we did on classifying triangles. So for our next column, we're going to look at the kind of triangles and the angles. So here's classifying triangles based on angles. So look at each of the pictures. Are all 3 angles less than 90 degrees? This one's less than 90, this one's less than 90, but this one is 90 degrees. Looks like the corner of a square. So if one angle is equal to 90 degrees, we have a right triangle. So in your column, you're going to write right. All right, next we're going to be figuring out what kind of triangle it is based on its sides. So we are classifying triangles based on side length. So this is a little excerpt from when we did our classifying triangles. Let's look. Properties. Are 3 equal side lengths? Does this one have 3 equal side lengths? All 3 sides are the same? No, it does not. So we know that it is not equilateral. Do 2 sides have equal length? 2 equal side lengths. These we can see the units here, 1, 2, 3, 4. And here we can see 1, 2, 3, 4. But here it's more than 4. 1. It looks like it might be 4, but it's actually more than 4 because if we moved this purple one down, it would be longer than the green one. So 2 of the sides are equal length, so we call that isosceles. And it's written right here. I-S-O-S-C-E-L-E-S. Isosceles. All right, now we're going to look at the ordered pairs for vertices. Now, remember, an ordered pair is when you write the x-axis number, then a comma, and then the y-axis number with parentheses on the outside. So let's look. We're going to look at the green point first. Here is the green point. On the x-axis, the green point, so we come down to the x-axis, which is right here. The green point is at 5. So I'm going to write 5, comma, and then go back to the green point and look at the y-axis. We go over to the y-axis. It is at 9. So our ordered pair is 5, 9. All right, now it's time to look at the blue point. So come up to our picture, look at the blue point. Here it is. We're going to look at the x-axis first. So let's go down to the x-axis. It is at 1. So we'll write 1, comma, and then we'll go back to our blue point and look at the y-axis. And the y-axis is at 5. So 1, comma, 5 in parentheses. Lastly, we will look at the purple point. Here is the purple point. The x-axis is 5, and the y-axis is 5. And put your parentheses around it. There we have our 3 ordered pairs that make up the triangle. All right, because we don't have a triangle from yesterday to compare this to, in our transformation column, we're just going to put an X because our triangle hasn't transformed because it's the first day. All right, let's move on to day 7. Here on day 6, we can see the shape of the triangle has the right angle in the bottom right-hand corner. And over on day 7, when we move to day 7, the triangle is facing the same direction. The right angle is still in the bottom right-hand corner. So when we sketch our right triangle, it's going to look the exact same as it did on day 6. All right, here is an excerpt from our triangle classifying page. Let's look at the kinds of angles in a triangle. So are all 3 angles less than 90 degrees? This one's less than 90 degrees, this one less than 90 degrees, this one is 90 degrees. So when one angle equals 90 degrees, we call it a right triangle. So again, it's a right triangle because it looks the exact same on day 7 as it did on day 6. Now let's look at classifying triangles based on side length, because in this column we're looking at the kinds of triangles based on their sides. So equilateral is when all the side lengths are the same. 3 equal side lengths. This one has 2 equal side lengths, but this one is slightly longer. So if there are 2 equal side lengths, we call it an isosceles triangle. So we write isosceles. And we know that that is correct because it's the exact same triangle that it was yesterday, only it's in a different place on the coordinate grid. Now let's look for ordered pairs for the vertices. The vertices are the points. Now let's look at the ordered pairs. The green point first. Here is our green point. And remember we're looking at the x-axis, then the y-axis. So the x-axis is at 4. So we will write 4, comma. And we'll go back to our point and we look at the y-axis, which is 9. So our ordered pair is 4, 9. Now it's time to look at the blue point. Our blue point, remember we must look at the x-axis first, even though it's on the y-axis. So look at the x-axis. It is at 0. 0, comma, and then look at the y-axis. Oh, we're already on the y-axis. It's at 5. 0, 5. Now we will look at the purple point. Purple. The x-axis is 4. So write 4, comma, and then the y-axis is 5. Ordered pair 4, 5. So just as a reminder, transformation is the way a shape moves on a coordinate grid. So here I have day 6, and here I have day 7. And it has changed just slightly on the coordinate grid. Some of you might be able to easily see how day 6 is different from day 7. And you can see in the ordered pairs that they are slightly different. The second numbers are the same, but the first numbers are a little different. So in order to show you, I'm going to draw this on this larger picture right here. And since this is day 7 already drawn, I'm going to draw day 6. So I'm going to look 5, 9. I start 5 on the x-axis, and I go up to 9 on the y-axis. So I'm going to draw my point right there. Now I will look at my second pair, 1, 5. So I come to 1 on the x-axis, and I go up to 5. Here I'm going to draw my point. Now I'll look at my third ordered pair, 5, 5. So I start at 5 on the x-axis, and I go up to 5 on the y-axis. So there are my 3 points. Now I'm going to connect them so I can see the triangle. And you must remember, the gray triangle I just drew was the triangle from day 6, or the day before. So the triangle was where the gray one is, and it has moved to where the colored triangle is. So we can see that the triangle has moved to the left. Now, just as a quick reminder on our vocabulary for geometry, when something moves or slides to another place on the coordinate grid, which is right here, slides, when it moves to another place on the coordinate grid, we call it translation. So in our transformation box, we are going to say that it translates, and each of the dots move from here to here. That is 1 unit. From here to here is 1 unit. From here to here is 1 unit. So it went left, translates left, 1 unit. Go ahead, pause the video and write that down. Okay, time for day 8. Go ahead, sketch the triangle right here. We can see that this day 6, day 7, and day 8 all have the same shape. So we can see this is still a right triangle. There's still a 90-degree angle. So the angles would be that it's a right triangle. And the sides, there are still 2 sides that are the same length and 1 that is a different length. And we call that isosceles. Alright, here's a bigger view of day 8 right here. Let's look at the ordered pairs, starting with the green point. The green point is at, look at the x-axis, 4, comma, and on the y-axis it's at 8. 4, 8 in parentheses. Then we'll look at the blue point. The blue point is at x, 0, and y is at 4, already on the y-axis. So we write 0, 4. Now the purple point. On the x-axis, it is at 4. And on the y-axis, it is at 4. So our ordered pair is 4, 4. Now, for transformation, the way the shape moves on the coordinate grid, again, I'm going to look at the previous day's points and plot it on my chart, my coordinate grid. So first we have 4, 9. So I'm going to go to 4 and then go up to 9. There's my first point. Then I go to 0, 5. 0 on the x-axis, 5 on the y-axis. There's 0, 5. And then we have 4, 5. 4 on the x-axis, 5 on the y-axis. Now I've connected all of my points to make the triangle, and we can see that it was where the gray one was, and that now the triangle has moved down. It has slid down. When we say slid, we know that it means translates. So in transforms, I'm going to write translates, and then I'm going to see 5 move down to 4, so that's 1 unit. Here is 1 unit, and here is 1 unit. So it translated down, because we see that it moved down 1 unit from day 7. All right, here we are on day 9. You can sketch the triangle here. Look at the triangle. Is it a right, acute, or obtuse triangle based on the angles? And then in the next column, we will be figuring out based on the side length, is it equilateral, isosceles, or scalene? Pause the video, write those down. All right, now I've enlarged day 9's coordinate grid. Let's look for the ordered pairs for the vertices. Green. Here is green. Green is on the x-axis is at 8. 8, comma, and on the y-axis it is at 4. So we have 8, 4. Now let's look at the blue point. Blue. Blue is on the x-axis at 4. And on the y-axis at 8. So we have ordered pair 4, 8. Now the purple point. On the x-axis, it is at 4. And on the y-axis, it is at 4. Which is the exact same place that it was on the last day, on day 8. Great. Now let's plot the points for day 8 and see how the triangle has transformed. So I'm going to start with 4, 8. We have 4, and we go up to 8. So this is the point where the green point was last time. 4, 8. Then we have 0, 4. 0 on the x-axis, 4 on the y-axis. Right here. And then our last point is 4, 4, which is the same place that purple point is this time. 4 on the x-axis, 4 on the y-axis. Now I'm going to draw my lines to make my triangle. And remember, my gray triangle is where it was last time. So we can see that this purple point has stayed the same, but the other 2 points have moved. Blue point went from here to here. Green point went from here to here. So we can see that based on our geometry vocabulary that we studied, when something turns, when the shape turns like this, we call that rotation. So in our transformation box over here, we're going to write the triangle rotates. This is the tricky part. Here we had a right angle, and here we have a right angle. So we can see that if we go from this right angle to this right angle, that we're rotating 90 degrees, because that's a right angle. And when a shape moves this way, the way a clock moves, we call it clockwise. So we say that the shape rotates 90 degrees clockwise. Because it goes the same way that the clock did, and it was 90 degrees. It moved a whole, looks like from one right angle to the next right angle spot. Day 10, the last part of triangle B. Woohoo! Let's draw your triangle in this box. Decide what kind of triangle is based on the angles. Is it right, acute, or obtuse? And in this column, you're going to figure out what kind of triangle it is based on its sides. Is it equilateral, isosceles, or scalene? Here is day 10 enlarged, and we are going to look for the ordered pairs. The green one is first. Green point right here. The ordered pair is the x-axis is 8, the y-axis is 4. So our ordered pair is 8, 4. Moving on to the blue point. Here's the blue point. Our x-axis, we're already on it, is at 4. Our y-axis is at 0. We have our point 4, 0 in parentheses. There's our ordered pair. And the purple point right here. The x-axis is 4. The y-axis is 4. So we have the point 4, 4. Okie dokie. Transformation. Where the shape moves on the coordinate grid. So I'm going to look at my day 9 triangle, which is this one right here. And I'm going to draw it in gray. So we have point 8, 4 on day 9. 8, 4. There it is. Let me put a dot there. Now we have 4, 8. 4 on the x-axis, 8 on the y-axis. Here's my next point. And 4, 4. 4, 4. Now we can connect our 3 dots to make our triangle. Okay. This triangle should look the same as the one on day 9. We can see, yes, they are, the blue line is on the 4 x-axis right here. So yes, that does look correct. Now, just like we explained yesterday, the green points are the same on these 2 days, and the purple points are the same on these 2 days. So my purple point is here, and my green point is here. Those are the same. So although you might think, oh, we just rotated it, we did not, because if the green and the purple points are the same, they're here, only the blue point moved from here to here. So really, it just kind of folded over. So on our geometry vocabulary, if two of the points are the same, like down here, and it just kind of flips over the x-axis or y-axis, which ours flipped over the x-axis because it was going side to side, we call that reflection. So in our transformation box, we're going to write reflects because it's reflected over the, what did we call this? The x-axis, because it goes left to right. Reflects over the x-axis. Great job! So make sure you have these parts filled in with your answers. And that is all for Triangle B.